Okay, so after we've just tried and we did our Frank and Gertrude's and our numerous functions, remember f of x is the name of the function. So sometimes you have lots of names. So again, we can use Gertrude because it's such a great name. Gertrude. I got Harry because that's my h of x. Maybe we'll keep with Frank. And then J can be Jenny. So it's just notating exactly which function that you're supposed to use. So in this case, you got to be very careful, though, that you don't get excited because you see an equation you like better and jump on the wrong one. So like number 1 is Gertrude 10. So I need to go to function g of x. X was replaced with a 10, so I'm going to do exactly that in my equation. So negative 3 times 10 is going to be a negative 30 minus 1. It's going to give me a negative 31. So when x is 10, y is a negative 31. So again, when x is 10, y is a negative 31. Or when g of 10 is equal to a negative 31. All right, so that's where we put a 10 in the place of x because that's what it is. What is the value of x if g of x is equal to 16? So what is the value of x if g of x is equal to 16? So in this case, g of x equals 16. Just like up here, g of 10 equals a negative 31. But in this case, we knew our x value. Now we don't know our x value. They've given the output. So 16 is an output now, and it's asking for the x value, which remember is your input. So I'm going to take Gertrude, and I'm going to put a 16 in the place of g of x, because g of x is 16. So if you learn to read this as is instead of equal to, sometimes it makes it stick a little bit better. So g of x is 16. Our Gertrude function was negative 3x minus 1. And now we're just going to solve for x, because that question, again, is what is the value of x if we're given our y value. So we're going to add 1 to both sides. So I end up with 17 equals a negative 3x. Then we're going to divide by 3 on both sides, or negative 3 on both sides, because that's multiplication. And so when y is 16, x is going to be 17 over negative 3. Or as a fraction, it would be 5.66, I believe, if I'm not mistaken. And remember, it's a negative. So we can leave this as a fraction right now because this is not a beautiful one. They're not always going to be that messy. But fractions, they do exist. So fractions are a thing. So the question is, what is x? X is 17 over 3, and that fraction is negative. F of 3. So again, this was where our input goes. So it doesn't say f of x is 3. It says f of 3. So we're going to go find Frank, which was x squared minus 7. X squared minus 7. We're going to plug in that 3 in the place of x, and then we're going to solve. So 9 minus 7 is 2. So when x is 3, y is 2, or f of 3 is equal to 2. There's another way to discuss it again. So what is x if f of x equals 23? So again, x is there. F of x is the same thing as y. So what is x when y is equal to 23? In Frank's function, again, was that x squared. So we're going to put 23 equals x squared minus 7. And then we have to solve for x. So we're going to add 7 to both sides. And that gives us a 30 equals x squared. To get rid of a square, the inverse operation of squaring something is square rooting it. So we're going to square root. So x is going to equal to the square root of 30. And you can either leave it as the square root of 30 because that is just a mess and it's not a beautiful number. Or if you do it in your calculator, the square root of 30 is 5.48. If we round appropriately, 5.48. So x is 5.48 when y is 23. The most accurate answer, though, would be that x is the square root of 30 when y is 23. So when x is the square root of 30, y is 23. Number 5, so h of negative 2. So pause the video and see if you can use Harry's function to figure this one out. H of negative 2. So again, this is my input. So I'm going to take Harry function, which is 16 divided by x. And I'm going to do 16 divided by that negative 2 because it's in the place of x here. It's going to go in the place of x in your function as well. And that's going to give me a negative 8. So when x is negative 2, y is a negative 8. So again, when you see h of x and the x is gone and there's a number there, it goes in the place of x, just like it looks like it would. And then what is the value of x if h of x is equal to negative 2? So these two are using the exact same numbers, just so you can see the difference in the notation. This is in the place of x. This is on the other side of the equal marks, and this is basically saying y equals a negative 2 because h of x is the same thing as y. It's just notating that it's Harry function versus Gertrude, Frank, or Jenny. So at this point, if I use my Harry function, which is 16 over x, then y is negative 2. To get the x out of the denominator, because it's 16 divided by x, we're going to multiply both sides by x. Negative 2x equals 16. We need x by itself, and that negative 2 is multiplied. So we're going to divide by negative 2 on both sides, and x equals a negative 8. So x is negative 8 when y is negative 2, or y is negative 2 when x is negative 8. All right, guys, hopefully that made some sense. Last but not least, on the other side, this also pertains to tables. So one of these is going to make more sense to you, but hopefully by trying all of them, it'll start to stick. So can you figure out what this notation means? So f of 2 equals 12. F of 2 equals 12. Remember, this is f of x equals, and that means y equals your y number. So that's when x equals 2, y equals 12. So f of 4 equals 24. And when I go over to 4, I go all the way up. It's 24. So when x equals 4, y equals 24. And as a coordinate, we know that that is 4, 24. So again, we have f of 0 equals 0. So when x is 0, y will be 0. And that coordinate would be 0, 0 right here. So using your table, can you fill in the missing blank? So f of 1, so that's saying what is y when x is 1. So if I go to my table where x is 1, it's 6. So time and boxes packed. So at 2 hours, there was 12 boxes packed. At 4 hours, there was 24 boxes packed. At 0 hours, there were no boxes packed. At 1 hour, there were 6 boxes packed. And then at 3.5 hours, so if we go to 3.5, there are 18 boxes packed. So the y value is 18, your output. Oops, sorry, I don't know if I was up there. So at 3.5, that's between 3 and 4. And then I'll look over, I see 18. So that coordinate is 3.5, 18 up there. And remember, f of 3.5. I'm saying when x is 3.5, what is y? The bottom two are the y is given. So if we go to our table, we have f of something equals 3. So it's 3. So we're going to go to our y value of 3 and go figure out what our x value. And that's 1/2. So that's 0.5, 3 as a coordinate. Or when f of 1/2 will give me an output of 3. So when x is 1/2, the y value will be 3. Then 9, so we're going to go up here to 9 and go see what the x value is, because that number is on the outside of those equal marks, so that's the output. And then we come down, it's 1.5. So 1.5, 9. So f of 1.5 will give me an output of 9. All right, guys, good luck on your practice. Hopefully that makes sense. Call me, email me, text me, all the things you need to if you have any more questions on function notation.